Hi, welcome to Advanced Math, Unit 12 on Vectors, Part D, page 5. Well, we're going to do a few examples of what we've learned so far. First off, example 9, find the equation of a line that passes through the point 2, 5 and is perpendicular to vector u, which has components of negative 1, 3. So, what we're going to do is we're going to take the components of vector u and use them to form the linear equation. So the x component becomes the coefficient for x, the y component becomes the coefficient for y, and we add those together and it's equal to the c value, which we don't know what it is yet. Now it goes through a point, so we should be able to plug the point 2, 5 into our equation, and it will still work, and we can use that to figure out what c is. So we'll substitute in. So this is negative 1 times 2 plus 3 times 5, which is equal to 13, which is equal to c. So finally, our linear equation is negative 1x plus 3y equals 13. So that's a line that should pass through the point 2, 5 and be perpendicular to vector u, whose components are negative 1, comma 3. Example 10 simply says, hey, this absolutely should work, but let's just double check and make sure that the point 2, 5 works in this equation. So we'll plug that in. Negative 1 times 2 plus 3 times 5. Well, yeah, of course it works because we use that to get 13. Absolutely. All right, let's try a three-dimensional version of that. So we're going to find the equation of a plane that passes through the point 2, or negative 2, 6, 8, and is perpendicular to the vector u, whose components are 5, negative 2, and 30. So again, we'll use these components of the vector to form the plane equation. So this will be 5x minus 2y plus 30z. And we usually wouldn't call it equal to c, we'd call it equal to d because, well, it's, because. And so this is the equation for the plane. We don't know what d is. The d is determined by deciding that this plane has to go through a particular point. So if we know a point that the plane goes through, we can or substitute the coordinates for that point into our equation to solve for d. So passes through, the plane passes through, I should say, negative 2, 6, comma 8. So let's go with that. So we have 5 times negative 2. So the x is negative 2 minus 2 times the y, which was 6, plus 30 times the z, which was 8. That's what d is equal to. So all we need to do is evaluate this. That's negative 10 minus 12 plus 240 equals 218, which is d. So it means we can write our plane equation in its final form. We have 5x, it's coming from up here, minus 2y plus 30z equals, not d, but 218. And there's our finished equation. And just to confirm that negative 268 works in there, we can substitute that back in. 5 times negative 2 minus 2 times 6 plus 30 times 8. I mean, we actually, really did that here already, so this is not much of a stunt. Really just explicitly saying that the equation that we get needs to be satisfied by this point that's on the plane. And the reason we include this here is that if you've made a mistake, followed an incorrect process, and come up with some kind of equation here that isn't that, then you would find that this point doesn't work in the equation. So when you're doing this, you should be winding up with a working equation. So when you evaluate this, you get 218 equals 218. Yes, that works. All right, well, that's the end of part D.